Learning goal number 10, solving one-step equations. Okay, learning goal number 10 is solving one-step equations. And when I say one-step equations, that means there's one thing happening in the equation. And when I refer to equation, I obviously refer to something with an equal sign, and we're trying to solve, that's the process of which we're trying to figure out the solution for x. What makes a statement true? Okay, first thing we need to do is talk about inverse operations. These are two operations that are opposite of each other. For example, addition and subtraction, multiplication and division. To get rid of addition, you use subtraction. To get rid of multiplication, you use division, and vice versa. You use inverse operations to solve for something. Let's jump right into examples to fully understand what we'll be doing here. Okay, here we go. Example number 1, x plus 5 equals 11. So the goal here is to solve for x, to figure out what x can be. Now I know this is very basic, you could probably come up with the answer right now, but it's a matter of understanding the process. And here's what you need to do. You always need to look at what is happening to x. So you need to look at what's happening to x, or look at what's happening to your variable. And from there, do the opposite. So look at what is happening to x and do the opposite to both sides. For example, right now x is being added by 5. So if I want to solve for x, I want to get x by itself. I want to get x by itself. So what I need to do is I need to take this plus 5, and the opposite of addition is subtraction. I need to subtract 5 from both sides of the equation. And when I refer to both sides of the equation, the equal sign marks the middle of the equation. So whatever I do to the left, I have to also do to the right. I was adding 5 to x, so I need to subtract 5. 5 minus 5 cancels, and x is going to be equal to 11 minus 5, or 6. So x equals 6, and I can solve this by just plugging 6 back in for x. 6 plus 5 equals 11. Good, done. Okay, moving on, example number 2 here. F minus 10 equals negative 11. If you look, F is being subtracted by 10. F is being subtracted by 10. If I want to solve, I want to get this variable by itself. I want to get that variable by itself. And to do that, I do the opposite of what is happening to it. It's being subtracted by 10, so I add 10 to both sides of the equation. When I add 10 to negative 10, it cancels. We're left with just F over here, and that's going to be equal to negative 11 plus 10, which is negative 1. You can check your work. Plug negative 1 back in. Negative 1 minus 10, or negative 1 plus a negative 10, gives you negative 11. Okay, so in this case we had subtraction, and we did the opposite, addition, to solve. Okay, example number 3, negative 2x equals 12. Right now, x is being multiplied by negative 2, and I want to solve for it, so that means I want to get it by itself. So what I need to do is, to get it by itself, I need to get rid of what's happening to it, which is multiplication of negative 2. The opposite of multiplication is division. So what I need to do is I need to divide both sides by negative 2. Be very careful with your signs. You're multiplying by negative 2, so you have to divide by negative 2. Negative 2 divided by negative 2 cancels. You're left with x, and that is equal to 12 divided by negative 2. A positive divided by a negative is a negative. 12 divided by 2 is 6. So your solution is x equals negative 6. Again, you can always check your work. Plug negative 6 back in for x. Negative 2 times negative 6, positive 12. We are doing multiplication. To solve for multiplication, you have to do division. Okay, example number 4, x divided by negative 5 equals negative 3. I'm going to mark the middle of my equation here. If I look, I ask myself, I want to solve for x, so I want to get x by itself. What's happening to it? X is being divided by negative 5. To get rid of division, we use multiplication. So I'm going to multiply this left side by negative 5, and I'm going to multiply this right side by negative 5. Now here's the thing. When I multiply by something and I'm dividing by the same thing, they cancel. The whole point is to get x by itself, and to do that, you do the opposite operation. And x is equal to, Over here, negative 3 times negative 5 is positive 15. Again, you can check your work. 15 divided by negative 5 is negative 3. To solve division, you get rid of it using multiplication. All right, let's do one more example here. All right, so this one can be very tricky. It can be very tricky, but what is happening right now is x is being multiplied by 2/3. And if I want to solve it or get it by itself, what I need to do is I need to get rid of multiplication of 2/3. So normally you would divide by 2/3, but we don't divide by fractions. Instead of dividing by fractions, we multiply both sides by the reciprocal. Instead of dividing by 2/3, I'm multiplying both sides by 3/2. Don't divide by a fraction, multiply by the reciprocal. Instead of dividing by 2/3, we multiply by 3/2. When we multiply by 3/2, it cancels the multiplication of 2/3, and we get x by itself. We go over here to take a whole number times a fraction. You take the whole number times the top. 6 times 3 is 18. And then you divide 18 by 2. You get 9. Okay, again, you can always check your work. 2/3 times 9. 2 times 9 is 18. 18 divided by 3 is 6. Hey, try these problems now.